Hi, my name is Jess, and you're here watching this video because you want to learn how to segment out an endocast volume from CT scan skulls. Or you can even do that with teeth. And this is a teeth segmented out from a permiscus, which is a deer mice, using the software 3DSlicer. Let's get into it. To start with, you will need to download 3DSlicer and add in the slicer morph extension, and you also need your data that you're working with. There are a couple of tips that I learned throughout my process of using 3DSlicer. The first one is always save, and then there's also the option to customize your toolbars to accommodate for your workflow, which I find it very helpful and make my process very efficient and increase the productivity. And update the versions very carefully. And the last one is there's a GitHub forum available, which you should always ask questions on there. Slice and Morph extension download is very easy, and then just install the extension. There are also a lot of documentations available on their official website. For files, in this case, I have some that are ready for my project. But if you don't have any data ready, my favorite open source website is Morphosource, and from there you can download a lot of open source scans, and a lot of them are high quality and great for practice. And you can just follow their download instructions. There should have everything, including the image stacks and also a sheet of metadata of how much resolution it's scanned at. Then you can see the specimen number. Some of these are really precious because they have a lot of other ecological data associated with the specimen. So I'm going to say download, and I'm going to write below. And you agree. All right, now it's zipping. To change the modules toolbar on 3DSlicer, it's actually quite easy. So all you have to do here is to go to Edit, and you can click Application Settings, and then you can see this modules one. I have aligned them very particularly to my workflow, and once you have fidgeted it to the way you wanted it to be, you can just click OK and it will show up here. And you can also choose to show this toolbar, which is, I believe, all the markups. If you do not have this image stack module on your toolbar, you can also click this search and just type in image stacks, and this is the module you're looking at. If you do not have it whatsoever, you should open up your extensions manager, and you should check if you have Slice and Morph installed. And if you do not have Slice and Morph, you can go ahead to install the extensions. And now we can finally start importing our images. I'm going to select the first image in my series, and I will then change my resolution to according to what I have. And usually if you download something from Morphosource, there's another file that will state the resolution. And you need to be careful here for the unit and make sure you entered it and converted it in the unit, so then later on your measurements are accurate. So we load the preview here, and let's check up on our preview volume. And to do this, you need to switch over to volumes module and just click on the I button, and it will show you on the right side on the 3D view. Then you can toggle the slider to the point where the intensity is just right. And in this case, I will stop right here, which allows you to see the full body scan of my specimen. Sometimes you will come across multiple specimens in one scan. How I deal with this is, say for this scan I want an entire body scan, and I also wanted another volume for just the skull. So I'm treating them as two different projects that I'm going to work on. So what I will do is, first I export the full resolution of the entire volume and I save them right away. Then going back to the volume module, I'm going to enable this crop option, and then it's going to show you this ROI box, which means region of interest, and you're going to toggle that ROI box to where exactly you want to be. So actually, if you have 5 more parts that you wanted to save individually, you can also create other region of interest boxes just by using the module crop volume, and then you can save them individually to different projects. And this is something that you need to be really careful to not mix up your specimens with the number and the labels, especially when they have associated data and you do not want that to get mixed up. Another tip over here is do not apply any transformation before you export it out of ImageStacks module. And this is because when you do apply transformation and then you do the crop actually will be done on the original ImageStacks orientation. So when you export, the bound will no longer be the same as after you transform and then you crop it. So it will result in incomplete specimen scans. And I have done that many times and causing many frustrations. Let's take a look at our volume. This is a superior view, and we know this obviously is the lower jaw, so that means we need to apply a transform on our volume. Here I click transform module, and I'm going to select the layer into transform. And how I know this is by going back to data, you see this tilted square. You're gonna right click and allow interaction. So you see this little circle, and by holding shift and dragging it to the center, I can roughly orient it to the right orientation. And here I turn on these reference lines on the top right, and I also turn on interaction. I usually put this through the midline and I just eye out to see as I go through the slices if things are stayed in symmetrical ways. After everything is taken care of, I roughly examine to see if I have my right and left side the right way, and I turn off the interaction and then I harden the transformation. You do want to turn off the interaction before you harden the transformation, and the way I know I have transformed successfully is by going back to transform module and to see the layer is no longer there. Taking measurements is also super easy. The module you're looking for here is the markups module. And here I just use the line measurement tools. For my protocol, I only had to do 6 line measurements, 3 on the left, 3 on the right, and then I just take the average. You can also set up codes, and you should look this up. It's available in the forum, so that when I press Command, Shift, and letter M, it will batch copy all the results. Once finished taking all the measurements I need from the 3D volume rendering, I just turn it off and head over to the segmentations module. I start off by adding a layer of segment, and using the threshold function, I look through each slices to make sure it captures the bone structures that I wanted to include in my segmentation. And here I just go through slice by slice in every single angle, and I look at if there are ways that I can better adjust the threshold. I turned the 3D view on, and then I copied my layer of skull, and I named this temporary. Going off to segmentations module, I changed the visibility so it's a little bit translucent, helping me to see through the structures. We wanted to cut off the structures to basically only neurocranium, so it doesn't confuse the algorithm later. I have used the scissors tools. I cut through the bulla on both sides and I cut off all the rostrum area. While this is not perfect, sometimes you do have to balance out the details versus how thick you want your bones to be. And here I thought this is good enough, so I went ahead and proceeded to wrap solidify module. So under the wrap solidify function, it's right here, and I believe you have to install Slicemorph to be able to have this extension. I choose the largest cavity, and I do split cavities. The 1mm threshold is what I have decided on based on trial and error, so I encourage you to try multiple times on different numbers and just adjust accordingly. And there's this awesome explanation on what split cavity exactly mean. This is from the forum, and I will attach this on the screen. You can pause to look at it. Once you have adjusted the threshold to whatever your desire, I then just click to new segment and I export to new segment. This is because if the one segmentation turns out not to be really ideal, you can always go back and do a new one. So because I already done this one time, so I have the actual endocast, and here's the result. So I usually flip over and look at every direction, and I also turn on skull layer just to see if there's any overflowing or weird interactions between the skull layer and the endocast layer. Once after I've done that, I go over to segmentations and I export the models as in their individual folder. I hit export, and there we have every single layer. I usually only keep the endocast surface models because I can use it for 3D printing, and also that's good for later to taking landmarks if you need that. So you can choose the types of models you're keeping, and I have found that PLY is pretty standard, or VTK works as well. And the module volume statistics is really intuitive to use, and you just need to select your segmentation and your volume, and you will get your results. And this is a good place to wrap up our tutorial for today. In the future, if you're interested in learning landmarks, placing landmarks on the volumes, or potentially you wanted to 3D print some of the volumes, such as this or this, there are plenty of documentations and tutorials out there, and I encourage you to follow those along. And thank you for watching. I hope this helps.